Okay, so in solving problems like this, so already we have finished with the um, calculation of forces that are three forces in equilibrium, or what we call three forces acting at a point. So, and then here we are going to look at when we have four or more than four forces acting at a point. So how do we find the resultant? So how we are going to be solving this one is going to be quite different from what we did in our last section. So looking at this, so the method we are going to be using here is resolution of vectors. So that's what we are going to be using here. So, and then we are going to resolve these forces into components. So we'll call that the horizontal and then the vertical components. So that's what we are going to be looking at. So how do we resolve these things into their components? So first of all, there are key words that you need to understand here before you start doing that. One is that you must make sure that you know the angles which each of these forces are making with the horizontal. So that's the first thing you need to think. So once you can understand the angle these forces are making with the horizontal, then you are good to go. So we call that word convention. So it's just a convention. You can actually use any other convention, but this is what we are going to be maintaining as far as this class is concerned. Okay, now let us take a look at these forces and then the angles they are making with the horizontal. So the 5 Newton force is making an angle of 90 with the horizontal. The 6 Newton force is already horizontal, so that means the angle it has with the horizontal is 0. Then 3 Newton forces is making an angle of 30 with the horizontal, and the 4 Newton force is making another angle 30 with the horizontal. So how do we now resolve this into components? So what we are going to be doing is that we are going to draw a line, and then we call this vertical component, and then we call this one horizontal component. Okay, so in each case we are going to be resolving vertically and horizontally at the same time. So let's start from this. So when we want to resolve this vertically, or we can see that this is already vertical. So, and then it has an angle of 90 with it. So how do we resolve it? We already know from our trigonometrical ratio what cos and sine is. So this is going to be simply positive. This is positive. This is positive. So here is negative. Here is negative. Okay, so here we have plus 5 sine 90, and then here we are going to have minus 6 sine 0. Okay, and then here is going to be resolving vertically is going to be minus 3 sine 30. Okay, and then this minus 4 sine 30. Okay, so these are the forces. Okay, so looking at this, sine 90 is 5. Okay, so here sine 0 here is going to be 0, so I have 0 here, and then sine 30 is going to be 0.5, so this is going to be minus 1.5, and then this is going to be minus 2, because sine 30 is 0.5 multiplied by 4 will give minus 2. So adding this this we now have minus this is going to give us a minus 3.5, and then minus 3.5 plus 5 is going to give us 1.5. So I think we have a 1.5 here, 1.5 as the vertical component. Okay, so coming to the horizontal component, so we are going to replicate the same thing. The only thing different is that the number is the sign is going to be different. So coming to this, I'll just write 5 cos 90, then I'll write 6 cos 0, and then I have 3 cos 30, and then 4 cos 30. Okay, so let's look at the signs here. So this is already positive, okay, which is here. Then this is going to be negative. This is going to be negative because it's pointing towards the westerly direction. So resolving this horizontally again will now be negative. So this is going to be negative, and then this one resolving it here is going to be positive. So this is going to be positive. Okay, so here cos 90 is 0. Okay, so we are going to write 0 here, and then cos 0 is 1. So 1 times this, we are going to have minus 6 here. Okay, and then I have 3 here. 3 cos 30 is 2.61. That's going to be minus 2.61. Okay, and then this one is going to 3.48. Have 3.48. Okay, so we are going to add. So when I add this 0.8, so I have minus. So here I have minus 5.13. So this is the to draw the diagram. So we can see that the vertical component is positive, the horizontal component is going to be negative. So okay, so let's see how we are going to draw it so that we won't be having issues. Okay, so this is a vertical component, this is positive, this is negative, this is positive, this is negative. So okay, for us to draw this now, so we can see that the vertical component is positive. So this is positive vertical component. So that means we are going to draw it here, the horizontal component. Okay, and then the horizontal component here, I have negative. So this is the negative horizontal component. So this is what I am going to do. So it is here and here. So my triangle is going to be this way. Okay, so that is going to be my triangle. Okay, I'll now clean it. So this is it. This is going to be 1.5 and this is going to be 5.13. So I am not going to be using minus here because this is the negative sign is just giving us the direction. So, and that is what I have shown here. So the direction here is negative. So there is no point adding the negative sign. So, and then the resultant R is this. So we are going to now use a Pythagorean theorem, which is R equal to 5.13 square plus 1.5 square. So, and that gives us the resultant force in this